In this section, we're going to look at some outboard effects, and in this case, we're going to be talking about and focusing in on compressors and gates. And most important of these is the use of the compressor. It's the key tool that sound engineers use to control volume. When we amplify musical signals, guitars, vocals, bass, drums, we increase the sound pressure level and we take things away from their acoustic default and we take them to a much higher energy level than they occupy naturally. It's important as we increase volume that we also have limitations and control over absolute level. You've heard that term before, that power corrupts and absolute power corrupts absolutely. We need to be careful that when we're mixing sound at higher sound pressure levels that we have control of the power. The role of a compressor is twofold. First of all, it's there to maintain the reduction of dynamic range so that we don't have any big spikes between what is normal, what is the average level, and what will be the peak output of any particular voice or instrument. The other role that a compressor helps us with is it keeps the dynamic range of signals within the capabilities of our own PA systems. The headroom resources that we have inside our amplifiers and our speakers are not infinite, they are finite. And if we take a signal and allow it to hit the top of that, we get limiting, we get clipping, and we get distortion. A compressor can help us keep everything within these limits. In modern mixing, it's likely that many of the channels will have compression inserted so that all channels have got this level of control. So how do we connect a compressor to our signal path? In an earlier module, we talked about gain structure and the path of a signal through a mixing desk. We realized that we go from microphone to mixing desk, and there we hit the microphone preamplifier. Here we apply some electronic gain. It's the main knob at the top of the channel strip. Really then the next thing that happens, we have an insert point within the mixing desk. We place often a jack cable with a tip, a ring and a sleeve. We leave the mixing desk, we go through the compressor, and then we come back into the mixing desk again, and then we carry on flowing down the channel through the EQ and through the auxiliaries. So the path is to the microphone preamplifier, then we take a little journey out of the mixing desk to the outboard effect, in this case a compressor, and then we return back to the mixing desk to carry on the flow as we did before. Can you therefore see that when we do compress, this pretty much affects everything downstream of that insert point? Let me explain what a compressor is doing. We have a really important graphic to share with you which shows on the x-axis we can see the input signal. This signal is showing us how hard the musician or vocalist is working. We can have everything from very quiet to medium levels to very high levels. On the y-axis of the graph, we can see the resultant output. And we expect, as the musician tries harder and gives more energy into the microphone, we get a corresponding and exactly matching output. For every decibel of input, there will be equal and an equivalent decibel of output. We are living in a linear world of what we will call a 1-to-1 ratio. For every 1 on the input, we're going to get 1 on the output. What a compressor is going to do is manipulate this graph so that it is no longer a 1-to-1 curve. It's going to change it so that we can make the musician or vocalist work harder for their 1 decibel of output. The role of the compressor is to make an uphill struggle for the musician to create more output level. A compressor has 2 controls which are most important. The first one is the ratio. This is the number that we choose. Instead of moving on a 1-to-1 basis, we're going to be able to change this to maybe a 2-to-1. This means that for 1 output, we're going to have to put 2 input. The only way you're going to get £1 is by giving £2. The only way you're going to get $1 is by giving $2. A compressor splits the world of input effectively into two halves. There will be one half below the threshold. This is the second most important knob on a compressor. We set a regime change. Below the threshold, we do no compression. We allow the world of 1 to 1 to be maintained all the way up to the threshold. If you make $1 more effort, there will be $1 more output, 1 dB for 1 dB. Below the threshold, therefore, we are working with linear acoustics. If we go above the threshold, we start to change the world according to the ratio that you've set. It would be normal for general compression of vocals, brass, guitars, keyboards, in fact, most of the instruments that we see across the channels of a mixing desk, to set a ratio of somewhere between 2 to 1 to 3 to 1. Let's call it 2.5 to 1. Why not? 2.5 to 1. This means that once we cross the threshold, for every 1 dB of output, we're going to have to put 2.5 dB of input. We're making the sound push its way up the hill. If you look at the two curves we have drawn on the graphic, the linear 1 to 1 range, and we have imposed over the top of that, at the threshold point, the new world of 2.5 to 1. If this process were to continue without compression, beyond the threshold we would just continue up the straight line of 1 to 1. However, because we have implemented a compressor, we have changed in the world of 2.5 to 1. Can you see that there is a difference between the 1 to 1 line and the 2.5 to 1 line? And the further we go into the input, the louder the input source gets, the difference between these two lines is greater. This difference between the linear 1 to 1 and the reduced 2.5 to 1 contours is what we call gain reduction. A sound engineer will be using this difference, this gain reduction number, to monitor how much compression is taking place. Let me take you through a typical compressor and the controls that we find on it. Now, a lot of these controls, to be honest with you, we can ignore. We're interested in two controls, the ratio and the threshold, and we're interested in one display, gain reduction. So this is a 2-channel compressor. It's a DBX unit. It's quite a common compressor, professional unit, and although it looks complicated at first viewing, the first thing to realise, it's just the repeat of the same knobs. So there are 2 channels here. There's 1 channel on the left and a second and independent channel on the right. So we're going to focus on the controls on the left-hand side. And these are this is the compressor channel that we've got inserted into by now our familiar microphone. Let's have a look together at the controls that we've got. Well, on a DBX compressor of this type, the first part of this is a gate. And we're not using the gate at all. In this example, we're just using the compressor function. So if you look closely at this knob, right when it's turned anti-clockwise, the gate functionality is turned off. So we can immediately forget the first 2 knobs. The second 2 controls are the 2 important ones that I told you about. They are, the first one here is the threshold knob, and the second one is the ratio knob. And earlier on we were saying that a good idea for a musical ratio is 2.5 to 1, somewhere between 2 to 1 and 3 to 1. So let me set that now. I've set the compression ratio somewhere between 2 to 1 to 3 to 1. You don't have to be too precise with this. Somewhere between those 2 figures is just going to be fine. If you have a look at the threshold, this is wound right out of the way. If you imagine back to the graphic, the threshold has been moved fully to the right-hand side. It's way out of the way of the input signal. This, on this compressor, means that it's been turned fully clockwise. We can change the speed of a compressor. We can make it work more quickly or more slowly. And we can also change its release. We have an attack and a release. The attack will speed up the compressor. It makes it clamp down very quickly or more slowly. And the release, once it's clamped down, the release changes the speed at which we let go again. We might use these with percussive instruments. However, for now, these are bypassed. If you have a look, we have got the auto light switched on. And on most good quality compressors, you will have this kind of functionality, an auto light, an auto function. And in this situation, the attack and the release are effectively bypassed, and the compressor itself is setting the values appropriate to the input signal. The final control that we need to worry about is the gain makeup control, or the output control. Compressors are going to work by generating gain reduction, a reduction in gain. And so to make up for this gain, the final stage of a compressor gives us the opportunity to return that gain back to the signal path so that we are maintaining gain structure. If you look closely at this gain knob, I've set it to somewhere around 6 dB. The reason I've set the gain make up to 6 dB is that when I set my gain reduction, when I tune the compressor into the signal, I'm going to be trying to achieve 6 dB of gain reduction. What I'm taking away with one hand in the dynamic way, I'm giving back with the other hand in a static way. So let me show you how it works. And I'm going to take the microphone, and we've inserted the compressor on the microphone. We can confirm that because you can see clearly on the input signal, we are monitoring the input level. So the microphone is going into the mixing desk. We have gain structure applied from the microphone preamplifier, and then we take our little journey through the compressor and back into the mixing desk again. You can see that we are properly inserted because I am seeing input on the input monitoring. You will also notice that currently there is no gain reduction. There is no gain reduction because we have the threshold wound clearly out of the way of the signal. So the objective with the compressor is to tune the threshold back until we meet the incoming signal. Let me show you doing that while I talk to you. So as I talk to you, I'm going down to the threshold knob, and I will slowly start to bring the threshold down to meet the signal until I monitor gain reduction. And there it is. You can see I am applying 6 to 9 dB of gain reduction, and we are compressing. If I talk quietly, you will notice there is no gain reduction. We have now moved our own effort below the threshold. If I talk with medium excitement, we will get some gain reduction. But if I go fully excited and I really start to increase my dynamic range, then the compressor will work harder and harder to compress. And you should be able to hear this as a squashing of the signal. Let me help you to hear this difference. At the moment the compressor is in, I'm going to bypass it. So by pressing the bypass switch, the compressor controls are effectively disabled and there is no compression. I'm going to give you my voice with very minimal effort. Here I am talking to you with minimal effort. Now I will talk to you with medium effort. This is me speaking to you with medium effort. And finally, I will talk to you with increased energy. We might be distorting the input to the DVD. This would be analogous with us distorting the input to your PA system. Let me now repeat that test with the compressor engaged. The compressor is now engaged, and I'm speaking to you with minimum vocal effort. If we look to the gain reduction, we're only seeing minimal gain reduction. I will now increase to medium effort. And now notice that the dynamic range of my voice has not increased. We have capped this in some way. And even if I speak with increased vocal effort, the compressor will be dragging the volume down. The objective for compression is to make sure that during program, we're running somewhere between 6, a maximum of 9 dB of gain reduction. If we run too much gain reduction, let me demonstrate. This is in the situation where we have the threshold set way too low, so we hit the ratio very easily. This will squash the life out of the signal. However, if we have the ratio set, and I'm just going to set the ratio way too far to the right hand side, this compressor will do nothing. If I don't see any gain reduction, the compressor is being non-effective. However, as I back the threshold back to meet the signal, we start to see our performance point, which is 6 to 9 dB of gain reduction. Many compressors have a feature which allows us to give them a softer knee. The knee shape is how we transition from the one-to-one world, below the threshold, into the enforced ratio. We can do that in a very sharp transition or a smoother transition. Compression can be sometimes heard as a very obvious artifact by the pumping or the sudden reduction of gain. A DBX compressor has the ability to turn on a softer knee, and they call this the over easy, quite an American term, but it means that the compressor is very easy around the knee point. Let me just turn that on now. With the over easy set, it means that we should ride the knee without it being so obvious to hear. If you now listen to my voice and the differences between the quiet program and the medium program and the very loud program, we should have a reasonably smooth transition from no gain reduction to full gain reduction. I hope this has proved a useful introduction to why we compress and how we compress. One of the things I wanted to say is that the control of level is so important when we're mixing live sound. Compression is going to be inserted on every channel, and it is the primary way in which we mix volume. Once a sound engineer starts working with multiple channels of compression, we almost stop touching the faders, and we start to balance the volume levels by the exact tuning of the threshold positions. If we want something to be a little bit more obvious in the mix, we will turn the ratio towards the right to allow the signal to live without so much commanding control. If we want to turn a signal down in the mix, we may choose to do it by turning the threshold to the left to increase the amount of control and the reduction of dynamic range that we have implied on that signal. Your ability to maintain many channels of gain reduction control is really one of the skill sets of a professional sound engineer. So these are the tools available at our disposal, but please be careful not to overcompress your mixes. This will make things sound loud, but with no change in dynamic range, which will be very lifeless and stressful. Without the control of dynamic range, things can have a lot of peaks in them that make them sound disturbing. If we imply too much control of dynamic range, we can achieve really loud mixes, but which sound lifeless. Neither of these scenarios are desirable, and the clever point is to ride between those two limits. Please do be aware that the most common place to insert a compressor is right at the beginning of the signal path. This does mean that the monitors, the feed to the monitors, although they are pre-fade and not affected by the position of the fader, they are, however, affected by the position of the compressor. A musician who has their personal foldback being compressed is generally not a happy musician. The general approach, therefore, is if you are mixing monitors from the front of house desk, is you need to be very careful with the amount of compression that you add. Maybe 6 dB gain reduction at a maximum. Another way of going, which can be very helpful to you if you have a small number of compressors available to you, is to insert them into the groups. When we insert a compressor into a group, we are effectively sharing a compressor out over a number of channels, the channels that are routed to that group. As a side effect, because monitors are sent before we go to the group, our compression is having no effect on monitors. This can be a very powerful way of gaining overall band compression without it being noticed by the musicians.